And now among the properties of logarithm, we have the following property. We generally take log base a of a number x that is raised to a power n. Taking this logarithm operation is equal to the following operation. Log base a of just the number x with power 1 now. And the power n can be multiplied in front as a product. So now it's a product between the power that was there previously with the x, but now multiplied with simply just log base a of x. In that reason, this rule by many professors is referred to as the power rule for logarithms. Now, be specifically careful with this name, the power rule, because in case anyone learning from this lesson is advancing to calculus, the term power rule will be used again quite intensively, but the power rule here we're doing is the power rule specifically for logarithms, because for anyone who will advance to calculus, there will be a lot of power rules used in calculus, but the power rule in calculus is completely different with the power rule for logarithms here. So just be careful with the name, the power rule. And so now, as far as an example, allow me to bring in the following example that demonstrate how useful this power rule for logarithms is. So in this example, let's evaluate. And so now in part A, allow me to show the following problem. Log base 3 of, in parentheses, fourth roots of 9. Now for this problem, simply as a computation problem, anyone can head right into a calculator and type in a calculator command to get the answer for this. However, if we know the power rule of logarithms and apply the power rule of logarithms, we can simplify the calculation a lot significantly before we can type it in the calculator. So now, before using the calculator, inside of the log base 3 here, I can see the fourth root of 9 as 9 raised to the power of 1/4 algebraically, because at anyone's level of mathematical understanding, then a root is a fourth root, for example, is referred to algebraically as a power, but power 1/4. So fourth root of 9 is the same as a 9 to the 1/4. And so now, realizing that what we're having here is a log base 3 of a power 1/4 of 9, I can rewrite this expression according to the power rule for logarithms as a 1/4 times log base 3 of 9. And so now I don't even need to use a calculator, as it turns out. Tentatively, the plan is to simplify the expression and use a calculator so that it can save the number of steps to the amount of operations that we need to use in a calculator. However, in this problem, it's simple enough where it's simple enough to the point where this is log base 3 of 9 equals this part right here where I underline log base 3 of 9 equals 2. And we have a 1/4 multiplied with 2. So this 2 came out from log base 3 of 9. So as my final answer here, and this is a multiplication, a product between 1/4 and 2, the answer reduces down to just simply 1/2. Or calculator will give a 0.5. And so, again, if we simply just type the entire expression right here in a calculator, it will take some time. And it also depends on how you operate with your calculator. But now with some understanding in math, with some understanding in the power rule for logarithms, we can easily manipulate that fourth root as a 1/4 power up to 9. And then now with the rule for logarithms, with the power rule for logarithms, we can bring the 1/4 to the front and multiply with the logarithm of logarithm base 3 of 9. And the 9 here is of power 1. And then now that log base 3 of 9 is simply 2. And the 1/4 multiplied together with 2 is giving me a 1/2 as the final answer. And so here it turns out we didn't need to use a calculator at all. And now as another computation problem which demonstrates how convenient knowing this power rule for logarithms can be for us. We can look at natural log of square root of 3. All right, so with a problem like this, if we hurry into using a calculator, let's look at the demonstration with the calculator. So on the calculator, if we directly punch in the entire expression, then we have the following. We have to type in the following. Natural log of, and then we need to bring in the square root expression, which makes it different syntax depending on the different calculator. So for the one I use right now, second x squared, that brings the square root. And inside of the square root now I will type in a 3. So really there are two operations inside of the log, and then we take a log. And then we have to get out of the square root and close the parentheses and type and hit enter. And this is our answer right here. And on a calculator that is even more basic than the previous version of the TI calculator, the syntax will happen as following. Natural log, and now we have to open a parentheses, and now we have to introduce the square root expression, and then in that parentheses we type 3, and we close parentheses, and we close the parentheses again. So now we can observe the levels of operations that we have to use. So there's a square root of the number 3, and then from the inside out we have the logarithm, and then close that final parentheses, and we hit enter. It will get us the answer just like the earlier calculator software that was using. But now, for some calculators that are not as advanced as the one we saw on the computer screen, then typing a syntax like this, typing an expression like this into the calculator, or punching an expression like this into a calculator is not as simple as it can be. So we can have a workaround solution. And thanks to the power rule for logarithms, we can do the following. Again, similar to what I've done in part A, we can see the square root of 3 as 3 to the power 1/2. And so this overall expression is the same as taking logarithm or natural log of 3 to the power 1/2. And so now, knowing the power rule for logarithms, I can multiply the power to the front as a coefficient 1/2 times in product with natural log of 3. And so now the 3 is only of power 1, where this is simply just one simple operation on any calculator. So natural log of 3 can simply be done, or can easily be done on any calculator, no matter how basic the calculator is. And we multiply that final answer with a 1/2. And so now on a calculator, we can obtain the exact same result here. And no matter how basic our calculator can be, we can still handle the problem easily with a little amount of operation involved. Natural log of 3, get an answer for that, and divide that by 2. That's one way. Or we can think of that as the answer previously multiplied with a 1/2. And this is our final answer. So the final answer now, admittedly, it must be in decimal, but we can easily obtain that with. So here, tentatively, I'm looking at how we can use the power rule for logarithms here effectively, even if we have a very basic calculator. So the final answer comes out, or the final answer here came out being 0.54931. Allow me to stop at 5 decimal places. And now, as another example, we can look at a few other computation problems. So let's evaluate, and in part A of our example. Let's evaluate 1/3 times log base 10 of 8. So, admittedly, with a strong or advanced calculator, performing a task like this is easy and can be done in no time. So, for example, if we're on an advanced TI-84 plus CE calculator where we have the flexibility to type in the entire expression 1/3 multiplied with log base 10 of 8 as one syntax, as one command, then on the TI calculator we can do the following. In parentheses, 1/3 times log base 10 of 8. And hit enter, and there we have our answer. And the answer will admittedly be very lengthy decimals. But now again, the main point is, what if we don't have a calculator as advanced as the one I was showing on the screen? What if we have a calculator that is a lot more basic than the one I had on the computer screen? Then before we use a calculator, so the basic idea now is that anytime we're having a very basic calculator, then we need to find a way to minimize the amount of operations involved as much as possible. In this calculator, in this advanced calculator, the calculator itself is strong enough to handle division and a multiplication and taking a logarithm all in one command. A lot of operations involved here. But now if we consider a calculator that is a lot more basic than the one we have seen on the computer screen, then we have to find a way to reduce the amount of operations, and we still want to get the same result. And so now, thanks to this power rule for logarithms right here, before I type it in the calculator, and here tentatively we're going to be working with a very basic calculator, then I can do the following work before I type it in the calculator. Recognizing this as a value in the product with a logarithm, then now I can think of this power rule for logarithms the opposite way, meaning I can bring the value in front of the logarithm into the logarithm as a power. So here I'm looking at log base 10 of 8 to the 1/3. So I'm using the power rule for logarithms in the opposite way, turning it from a product into a power. And in that way, now algebraically, inside of this log base 10 right here, 8 to the 1/3 is the same as log base 10 of cube root of 8. And for anyone with very little understanding in math, cube root of 8 is easily calculated as 2. So log base 10 of cube root of 8 is the same as 2. log base 10 of 2. So this final expression can be given to a calculator and easily obtain the final answer without too much operations involved. So now think about with a very basic calculator, we can just simply type a log base 10 of 2. And by executing this command right here, we end up with the exact same answer without typing in or without typing out too many expressions, too many operations involved in the calculation syntax, in the calculation command right here on the calculator. So now the final answer is approximately 0.30103 and allow me to stop at 5 decimal places. So now in the same example here, let's repeat the computation skill that we have done earlier in another problem for here. So now how about we're looking at 1/2 natural log of 9. So before rushing into a calculator, a more effective way would be bringing this 1/2 currently combined together with logarithm here as a product. Bring that 1/2 inside the logarithm and make it 9 to the 1/2 power. And now in the next step, we can easily recognize that 9 to the 1/2 power is the same as square root of 9. So the problem here turns out to be, the problem from the beginning is the same as natural log of square root of 9. And square root of 9 is easily recognized to anyone to be 3. So this final expression is simply what we just need to type into a calculator to obtain the final answer. So now on a very basic calculator, all we need to do is type in natural log of 3. And the answer comes out 1.0986, 1 and a lot longer. Approximately 1.09861 and a lot longer, but allow me to stop at 5 decimal places. And so again, this is the solution, provided that we already know how to use the power rule for logarithms. On the calculator, if we did not have and so on the calculator, I can repeat the exact same problem, but without using the power rule for logarithms. Then on a basic calculator, we will have to type in the following. In parentheses, 1/2 multiply with natural log of 9. So that is a lot to type right here. And this calculator is still strong enough to type it all in one command. And the answer comes out exactly the same. Or even with simpler calculator, or even more basic calculator, we have to type natural log of 9. The answer there will be divided by 2. So here it takes a lot of steps to get to that final answer. And so now with our understanding of the power rule for logarithms, we can easily turn that into a natural log of 3, and this is the only value that we need to type it in the calculator. So I highly recommend any of my students to use the power rule as a way to make some good planning before we use before we do an evaluation problem on the calculator. And now at a different example, we can look at the following problem. Let's simplify So now in part A, we can have a logarithm And here I use base 10, so log base 10 of x to the 5th power. So now with this expression right here, we have log base 10 of a logarithm. We have a logarithm expression where it says log base 10 of an expression x to the 5th. And so without having an actual value for x, then we won't be able to calculate a final value. But here at least we can simplify. So simplifying here is in the sense that we can rewrite the expression here so that the expression inside of the log will become power 1 in a simplified power. And so right here I can directly use this power rule for logarithms right here. So this power will become the number that's multiplied in front of our log operation. So log base 10 of x to the 5th becomes 5 times as a product here, log base 10 of x. And so now that's how I have simplified. So just as what I said earlier, simplifying here or simplification here means we simplify the power, we reduce the power inside of the log expression here so that we can bring it down to power 1. So here it's just a simple logarithm expression, log base 10 of x. And then the power becomes a number that's multiplied in front. So in part B of the same example, we can look at natural log of a square root of a. And so this is again a logarithm expression. We have a logarithm, and inside of the logarithm operation we have an expression square root of a. So now I see the square root of a inside the logarithm as a to the 1/2 power, and this expression is inside a natural log function. Okay, and so now with this, once we're at this step, we can directly use this power rule for logarithms and rewrite the expression as 1/2, where the power previously here with the a is now multiplied in front of the natural log operation. And here the natural log operation becomes simply just natural log of a, where the power for a now is reduced down to 1, just that simple power 1. And so this is another problem where we have simplified a logarithm expression into something like this.